Hello guys, welcome to Physics TV. I hope you all will be fine. Well, I can guess that you enjoyed and learned from my first video on projectile motion. I'm sure after watching keenly the second part of projectile motion, you will succeed to achieve all the objective what I have mentioned in part 1. So let's start second part with stimulated activity to give you quick review of part 1. Just watch carefully this stimulated video, a cannon, a ball is going to project it to demonstrate projectile motion, trajectory in the green color. Now the trajectory in XY plane. Again, watch the motion. Now let's see the direction of the velocity, initial velocity V. So this, it can be anyone. We can consider U initial velocity, we can consider V initial velocity. Mostly we take U and V, but not necessary. Any alphabets you can take, you can consider as an initial velocity. But the best way is usually we take the U, capital U, we take the initial velocity. Just watch after this. Now see that it's one of the component of the velocity v, because this velocity v is making some angle, acute angle with along x-axis. That's why when we resolve, it will make the two components. One, this vertical vy, where v subscript, this represent that this is the vertical component, the component along the y-axis. And just watch. See, horizontal component, Vx, over here, along x-axis. So also here, the Vx, so x subscript, this x represent what? That this component is along the x-axis. So it means that whenever we resolve any vector, this time we have velocity vector, so it gives us the two components, one along x-axis and one along y-axis. Along x-axis called horizontal and along y-axis called vertical component. See now, what I told you before, and I explained well in my first part of video of projectile motion. Alpha. Here alpha is the acute angle of the velocity v, which is less than 90 and more than 0. Now, in the same way, as I have explained before in part 1, that in each and every point, this point, this point, this point, except the highest point, this, each and every point on the trajectory, if I want to resolve the components of a velocity, of course, at each point, the direction of velocity will be changed, but it will produce both the components, the Vx component, horizontal component, and the vertical component from initial point till before the highest position and after the highest position to the bottom towards the x-axis. At any point, it will provide us both the components. But yes, the very important fact is what? That at the vertical position over here. So think what I told you in the part 1 video, that what is the conditions of the components at the highest point. Yeah, I think you are thinking right, that at the highest point, always vertical component of the velocity will become 0. Listen again, very important, and usually students here are confused that at the highest position, the vertical component of the velocity, it will be 0. So, but in all other points, wherever you will take the components, you will get horizontal and the vertical components. Now, let's move towards the derivations and some questions taken from the past papers. Dear students, in case 1, I explained you that negative sign will be taken throughout the trajectory. Whatever the positions or point you will take on the trajectory, the sign will be negative. But which time? When we are looking the sign of the G related to the motion of the particle, which is having projectile motion. Then we have discussed that negative signs will go with the G. Now in case 2, there's something different. It needs your concentration. So now I'm going to explain that what the sign you will use with the G with the reference of distance or displacement. Displacement or distance. But when we talk about the displacement, the distance, you know that one thing is very necessary. Without that, we cannot reach the displacement or the distance. And that is reference. Reference or reference point mean that the initial point, the starting position. So now I will explain that how we take the sign of G as positive or the negative, okay, related to the displacement or the distance. So here, if you look at the diagram, when I make this reference O at the origin, then if I take the distance till here, let's suppose this is point A, till I take distance till here, point B, here till suppose C, okay, till here, suppose this is at the highest point, and till here is suppose D, here suppose E point, F point, and E, F, and G, and as we have already I at the ground, back to the horizontal axis, x-axis, and this is y-axis. Okay, so now see if I'm taking the distance from O to A. So when I take the distance from here to here, when reference is A, so definitely what will be the nature of the displacements? It will be positive. Same thing if I take the displacement from O till C, O to C. So what do you think? This displacement will be positive or negative? Definitely it will be positive. And the same thing if I take from O till C, this point, from this point to this point. So O to C, this will be what? Also positive when the reference is O. Same thing if I take the distance from O till very just before from the highest point, suppose this is any point we can take L, then this is also positive. So keep in mind, my dear students, whenever, according to the reference, if the distance or displacement taken is positive, then G will be negative, opposite, opposite to the sign of the distance or the displacement. Okay, so keep in mind, just so then I'm going to change one thing that when we got the distance, where we have calculated the distance, we measure the distance for the any segment from origin O till the before of the highest positions, then we succeed to get what? The positive distance, the positive distance, the positive displacement, the positive displacements. That's why the opposite one will take the G will be negative. One thing. The second aspect is now, still same. When the reference, still we're talking about when the reference is O. In the previous discussion, I have taken the reference O. Now again, I'm taking the reference also O origin. Then see what will be happen. Now if again, I'm taking, so now this is the reference O. I'm taking distance till here A, till here B positive, we have discussed before, till here C positive, we have discussed before, just before the H, okay, suppose D also till positive, here till A means from O, then when I go till A, now what's happened? Here change has happened, here direction has changed, it has reversed, it is going backward now, the backside, the opposite directions. So in the opposite directions, that way now when I will say that when we measure the distance or displacement from O to A. So it will be what? This will be the negative. It will be negative. Okay, one thing. Second, suppose that if I say from O till, suppose this is F, O to F means the reference is same, is O. So, but because here the direction has changed, O to F, so this will be what? Also the negative. Same if you go till, suppose this is here, the G till O till G, O to G, what? Negative. So if the displacement is a negative, you're getting negative distance, then I know that now you can help me to tell me what will be the sign of G. Think. I'm sure that you're thinking right, okay, that here we have negative, so opposite will be the positive signs will go with the G. So this is what when we are taking the reference O. Okay, now the third thing, keep in mind this thing. Now I'm going to change the reference point. Okay, the reference that when the reference point, this is not O, I'm taking now the reference point, this the highest point H. Now this is the reference point. If this is the reference point, and if I want to measure the distance or displacement from H to E or any, I mean, you can take the positions A, or H means H to E, H towards E, then what will be the displacement? It will be positive because now we're starting from here, so positive. Okay, yes, when we go from the origin, we take the reference of the origin, then it's opposite, it is negative. But now if we take the reference, this highest positions, then easily we can see that if we go from this point to this downward, so because starting point is this, the reference point is this, that's why it will be positive. Okay, in the same way, if I take the distance from H to F, suppose this is the F point, F position, H to F also, this is what? This is also the positive. Okay, same thing if I take from H till, okay, if I take this last point, if I take the G, H till G, then what it will be? Same thing, it means positive. Okay, so now here we can see that all are positive. If all are positive, then which signs will go with the G? Think and think. I know that you can give the correct answer that if the sign with the distance or displacement is positive, so with the G the negative sign will go. Okay, so G will be the negative. So this was all about the sign with a G. Rather, we will use the positive sign or the negative sign. After this, now we will move towards very important part of this projectile motion topic, which is very important topic regarding to the your examination, which type of the curriculum you are following. So this video will be help you a lot to solve the past paper to get the good grade in your examinations. So next thing is what? This is the derivations. Derivation. So when we talk about the derivations, so it has the two basic parts. Which one? The derivations of the distance or the displacement. Displacement or the distance means that we will drive the equations of the distance and the displacement, and in the second part we will also drive the equations of what? Of the velocity, or also you can say the speed. The velocity, the equations, and the distance of the displacement equations. Okay, so we'll go ahead now. So first we will find the equations of the displacement. That rather, how many equations we have and how we can drive them. So we know that from kinematic equations, first equation of motion is what? First equation of motion related to the distance or displacement is S is equal to ut plus half a t square, where S is what? Distance or displacement. Okay, we also can take it as a height. It depends on the situations, what you are working at any time. You know initial velocity, t time, 1/2 the constant, a acceleration, and again t is the time taken. And the second equation of motion of the distance or displacement is what? That we also use very frequently. That is 2as is equal to v square minus u square. Again, same thing, 2 is constant, a acceleration as distance or displacement, final velocity, and u is the initial velocity. Okay, so and the other regarding to the these equations, we will use, of course, because we need the distance or displacement. So we have only the options. Rather, we use these equations or this equation. So and but when we will go to the velocity, the equation of the velocity, there we have what we will use. We have one option. So v is equal to u plus at, first equation of motion. Okay, v for our velocity, initial velocity, acceleration, and the time that we will use just to drive, just to get the equation, the formulas of the velocity components, or the distance or the displacement components when you're working on the projectile motion. Okay, just we go ahead to find out the equations of of the distance or the displacement. So again, then it has two parts. Which one? Horizontal, horizontal component. And if we need to find the horizontal component of the displacement or the distance, or if we need the vertical component of a distance or displacement. So we know that for the displacement where we use the s, and if we need the horizontal component, here we use the subscript x, which will represent that yes, this is the horizontal component of a distance or displacement. Same thing over here. If we use s and if we use over y, so what is this? The vertical component. Okay, because subscript is y, so the vertical component of a displacement. So let's see how we get the equations. So first I'm doing the horizontal component. Horizontal component. So as we know, as we have discussed before, s is equal to ut plus half at square. So when we will take half at square, and because we're working on the horizontal components, so what will be happen in all the equations, all the physical quantities, what we will take consider, it must be along the x-axis. It means that this will be as x, this already I wrote x, and here x. Okay, time we cannot take horizontal verticals, and the constant we cannot take. That's why now this is the final equations. After that, here is the important work. Now we need to replace the values to get the final equations. It's very simple. Just listen carefully. As x, that is our objective that we need to find. Ux, horizontal components. So before we have discussed what are the horizontal components. Okay, when we result at any points, here horizontal component is what? Ux, u capital X subscript cos of theta. What are the vertical component at any point? U and sine of theta. What u? Uy. Y component, horizontal component. So here what we need? The horizontal components. What it will be? U cos of theta and into time t plus 1 over 2. What about this ax? This thing is very important, ax. And I want that you just help me think about it. That now what can be the value of ax? What means of ax? Acceleration along x-axis. Think about it. I think you can reach easily. You're thinking right maybe. Okay, what? That yes, of course, we have discussed before in detail that always in the projectile motion. Along the projectile motion, always acceleration along x-axis is what? Is zero. Why? As there's a no force acting on that moving object. Moving object. On that object, there's a no force which is acting horizontally. If no force along horizontally, that's why the acceleration along x-axis will be zero. Because if no force, no acceleration. So here no horizontal force, so no horizontal acceleration. So this is the universal constant. Always we take ax means the acceleration along x-axis 0. So if this will be the 0, t, all these terms will be 0. It means now the finally I can write the equation as x is equal to u cos of theta into t. Okay, and this will be 0. So no need to write this, all will become 0. So finally this will be your equations, the horizontal equations of a of projectile motions. Let me write again. So here finally we got the formula as x is equal to u cos of u what? Ux, horizontal component. Okay, what here? Ux, u cos of theta, u cos of theta into t. What is u here? So the final result, no need to mention the x component. Even here also no need to mention because already here we have mentioned. So here not necessary, just directly you write u cos of theta. Okay, and so what is the u? This is the initial velocity, what it will be given towards that velocity on the behalf of which we have projected. We have throw this object in the upward direction to make the trajectory. That initial velocity. Okay, then we have its two components, each and every point, ux and just uy. That here we have taken one component ux, and this ux is what we have discussed before, u cos of theta. So finally we get the formula that if we need to calculate the distance horizontally, okay, the component of a distance horizontally, then we use this equation. Now just we'll go towards the vertical component of the distance. Also very simple, just see over here. Now if I say the same equation we have, I think better if I also clean it, can get the more space. So now this is our objective. Okay, so if this is the objective, what we have the equation, the distance or the displacement ut plus half at square. We are working for what? Here you will put the heading vertical component of displacement of the distance. So then you will change all. This will be y, this will be also y, and x will be also y. Okay, and of course, as I discussed before, no component has a vertical of the constant and also the time. Okay, so now we need to replace the values just to get the final equation of the distance vertically of the vertical component. So we know that, we know before, what we know before, that here Sy, what is the vertical component? Uy, vertical component. So here this is very important. Listen carefully. Many times here, I repeated in the part 1 also, in the part 2 also I gave you the revisions that at the vertical, when vertical space, the vertical distance, okay, the maximum, here the height, what we have here the vertical component? Can you tell me what will be the Vy? Yes, 0. Vy will be 0. The vertical component will be 0. Okay, so here means what are the velocity we have? Yes, here the horizontal components will exist. If we are taking a v, the vector, then it will be vy and the vx. Vx will be v cos of theta and vy will be 0. Because you are taking u, if we are taking u, okay, then what will be over here? That uy will be 0, okay, at this point, but and still horizontal, and u x it will be u cos of theta. It means that this term which is encircled with the red, okay, this is going to be 0, because 0 will multiply the t, all will become 0, then plus half. Now here that rather we take the plus or the minus 8 square, because here we have taken, but we have taken over here that there's the vertical positions over here, okay, and this is the maximum. At the maximum, what we use the g positive, the maximum height, keep in mind, maximum height we use g positive. So what will be over here? Half, oh sorry, this was square, half g t square. So if we rearrange it, we eliminate this one term because it is 0. So the final we will get the vertical component of the displacements, it will be equal to 1 over 2 gt square. So in this equation, in this formula, we easily can find the vertical component of the distance at any place, at any point, at any position throughout the trajectory during the projectile motion. Okay, so this was the regarding to the displacement, both horizontal and the vertical component. So I think now you remember that now we will go to what? Towards the velocity, component. Okay, so listen carefully, important but very easy, velocity. So now we need the equation for the velocity, its horizontal and its vertical component. Sorry, vertical component. vertical component. So how we represent this velocity? If we're taking v, so it will be horizontal vx. If we're taking u, it will be ux. Depends what we are taking at any time or what it is given in the question. Then you have to use the same one. Okay, over here, vertical component. If we're taking v, so it will be vy subscript, and here it will be uy. Yes, here one thing I want to tell you that sometimes you can see in some textbooks or the notes or in some teachers' notes or the explanations that this horizontal component ux, sometimes they also use say horizontal, they use the x subscript. So it's the same thing. Rather you are using ux, rather you are using the u edge. In the same way, for the vertical components, rather you are using the subscript uy, rather you are using the horizontal component, the vertical component. Here we use v, vertical component. So it's the same thing. Whatever you use the this subscript to represent, it is the horizontal, the vertical components. Okay, now let's move to find out to derive the equations. Okay, so as I have discussed before, we need the help of the equation of motions, where we not need the distance or displacement. So this is the one. This is the first equation. V is equal to u plus at, final initial acceleration and the time. Okay, and we are going for the horizontal. So when we go for the horizontal, okay, I'm going to skip one step. So it will be vx, it will be ux, it will be ax, and the time. Okay, so now just replace the value. So this is our objective. No need to replace this value because this we need to find Vx. And what is the Ux? Initial velocity. Initial velocity at any point, Ux is what? U cos of theta. So this is understood. I think now it is on your fingertip. U cos of theta. And again now here, one the important thing is Ax. Again this Ax. So what do you think? What do you think, guys, here? What can be the value of AX? Acceleration along x-axis. Think. I'm sure I repeated many times before this that what AX it is 0. Always acceleration horizontally during the projectile motion, AX is always 0. That's why the whole this term will be eliminated, it will become 0. And finally, you will get Vx is equal to U cos of theta only. Mean if you need the projected initial velocity, what the velocity with the velocity through which we have projected the object, the particles, to demonstrate to have a projectile motion, you replace the value of that one over here, and what the angle it is making with the horizontal axis, replace the angle. So in this way, easily you can get the horizontal component of the velocity. Now we will go to the vertical component of a velocity. Okay, so vertical component, very simple. Here one thing is very tricky, which you need to keep in mind always, where sometimes students make mistake. I'll just observe what is that. Vertical component. Vertical component of what? A vertical component of the velocity. Vy. Okay, alright, y is a subscript. So again, I will take the same equation. V is equal to, here we can say, as we know, V is equal to U plus AT, because we are converting it into the vertical component. So y subscript, okay, and t, we cannot dissolve it into the two components. Okay, so here this Vy, this is our objective. We cannot replace this value Vy. Yes, this we will replace Uy, and the vertical component at each and every point. So that we take here, or we take here at any point. What is the Uy? This is U sine of theta vertical component. And now here is a question that here's the tricky thing that Ay, that when we replace it into the G, so this G will be positive or negative. This now you have to decide. So please think and decide it. Rather, I will take this positive or the negative, the G over here. Think. Okay, I will give one clue over here that what here what is the vertical, the vertical the component of a velocity. Okay, so here vertical component of the velocity is what? We know that when we take the vertical components, okay, what happens in the vertical components? Vertical component of what? Of the velocity. Okay, that here vertical components, we take the negative sign for the verticals. So that's why what it will become minus. So A will goes to the, it will go with the minus sign as I discussed before. So what it will becomes G and T. So this will be the final equation of the vertical component of the velocity. So whenever you need to calculate the vertical component of the velocity, you will be VU, you sum to the velocity. Yes, sometimes here we can make a change. Mean by depending on the situation that at which positions we are considering the objects, then this can vary. It can go to positive, it can go to negative. But in standard, usually we take the negative sign when we're going to prove the equation of a vertical component of a velocity. Okay, all right. Now just go to the next one. Next thing what we have is very simple, that height. If we need to calculate the height of a projectile, then what you will do for finding the height? We need, as we know, again, the distance of the displacement equation from kinematics as is equal to ut plus half g and t square. So when we're going to the finding height, which the changing will produce, here it will be h, as will be go to the h, and u will be go to the y, and also g will also go to the y component. So all these will replace. So what will be the new equations for replacing these things? Height, even you can write s also, because s also represent the total height. Okay, so height into is equal to u, what? Vertical component. Here the so you can write u sine theta or uy and into t. Now plus here. So plus half, but what g now over here? Positive or negative? Again here this confusions, and you students here face problem to consider that at the height. So listen carefully. I am using the word height. Another thing is height, it can be this height, it can be this height, it can be this height, this one, this one, this one. All are the height at different positions. But maybe you have observed, I didn't see before this one. So what is this? This is the maximum height where we take positive, we have discussed before. And what about all of them? Here we are not sure. So if we are not sure about the height, just we are using the word height. Then now what will be the sign of G? Positive or negative? Think. Of course, negative, because it's not a maximum. It's not sure that here, this height, what we are taking, this is the maximum. If it is maximum, then of course it will be positive. But here, because it's not sure, then it will be the negative g into t squared. So when you finalize it, the height, it will be equal to u sine of theta, or simple, you can write uy, t minus. This will be multiplied with this sign, plus minus minus, it will be minus half g t squared. Okay. Alright, so this is the final equation with the help of which you easily can find out the height of a projectile at any point, at any positions. But if you're finding the maximum height, then this sign will be changed to the positive. Alright, after this, we have a few things more related to this one. Okay, what is the next thing? That is, this is the resultant vector. Mean, before we discuss the components. So if the component is given, as also we have discussed in this resolution of vector, if you have forgot the concept, so please wait for my video of the resolution of vector after a few days. So there we also we have discussed, or if you know before the resolution of vector topic, then we know that what are the horizontal components there. If we take u, vx, v cos of theta, Vy, if V is a vector, then Vx will be cos theta, Vy will be equal to V sine of theta. Okay. Then how we find the resultant? This resultant, whose components are these? These components. And if the components are given, we don't know the vectors. We have been given the components. If components, horizontal and vertical components are given, then it's very simple, it's very easy that we can find the resultant. How? Actually, this is using by the Pythagoras theorem. Here directly I will give you the concept. no need to explain over here. Vx square with the square of the horizontal component and the square of the vertical component whole root. So with the help of this equation, v is equal to vx square in horizontal component square plus vertical component square whole root. What the results we will get, this will be the resultant vector. Again, I'm telling you that if you have the components, then we can find the resultant in this way. At the same time, and after finding the resultant vector, because this is the vector, so we must need one thing more. What is that? That we must need to know its direction. Without direction, there is a no vector quantity. So it's also again simple. We just take the ratio of the vertical component and the horizontal component with the help of trigonometric ratio. So we know that. Again, this thing I will also explain again. The resolution of vector, that how we can get this equation. Tangent theta is equal to the vertical component over the horizontal component. Okay. Vy or Vx. So here, what would be the theta means angle? Angle of what? Angle of that concerned vector, which we succeed to get with the help of our components, rather mathematically, rather graphically. This thing I will explain in the questions. I think I was interested to solve question in this video, but now its length has increased, so I will make the another video where I will solve past papers questions regarding to the projectile motions. So there I will explain these things related to the question problems. So how we get then the theta? So we know that when the tangent will go other side, it will become tangent inverse Vy over Vx. So this is the equation with the help of which you easily can find the angle of the concerned vector which you got, which you have calculated with the help of both the components, horizontal component and the vertical components. Last thing in the derivation, that is the range. Range of a projectile like this. Here also the time of flight. Total time of flight is also taken as a t. This is not a time period. Okay, keep in mind. This t is not a time period. Okay, this is the total time of flight. And from initial point, from starting to the end point when it's going to hit the ground. Okay, so how much time it has taken from O till suppose E, that will be the total time of flight and it will be represented with a capital T. Okay, and again I'm saying here it doesn't mean that is the time period, because you know that time period is a time for one complete round trip, but here this is also by somehow we also can say, because the one not a round trip but one trip we also can say. That's why in the projectile motions always we take capital T for the total time of flight. So come over here, we know the formula for the velocity. It was v is equal to s over t, distance over time or displacement over time, and as after the cross multiplication we'll get s is equal to vt. So now because we are finding the range, horizontal distance, total distance covered, that's why this will be converted. We can write as x, but if we write as x, this will be the horizontal component of the displacement. That's why we make a change over here and we'll replace s by the r range. Okay, here s is equal to r range, this horizontal distance covered. And what about this way? The velocity, here velocity will take horizontally, the horizontal component. So what is the horizontal component of velocity? If here we have v, it will be v cos of theta. If here we take u, it will be u cos of theta. U v cos theta into small t. So this t will be go where? As I have discussed over here now before. So it will be capital T. Total time of flight. So it will be t. Okay. So in the finally, the results, the range equation, it will be equal to v cos of theta into capital T. Okay. With the help of this, we easily can calculate the range of any particles, any object which is having the projectile motions, where v cos theta will be as the horizontal component and t will be the total time of flight. When we just get the product of these two, then we will get the range of a projectile motion. Dear students, due to the large length of part second, I have decided to make the third part of a projectile motion, where I will explain the different types of questions, mean the different aspects of the projectile, maybe here I have left some deficiencies, so that deficiency will be recovered when I will solve the questions, not solve, I will explain the questions from the past papers. So at the end, I would like to recapitulate the topic. First of all, I would like to tell you, give you the review of the definition so you know it well. I have told you before many times. It's very simple that it is the just motion of any particle, any object in a curved path under the action of force of gravity. Then the second thing is the velocity. In the velocity, you must know that how that velocity can be resolved at any place, at any positions during the trajectory into its components, except at the highest point. At the highest point, the vertical components will be zero, but yes, and sometimes also we take the vertical component of the velocity negative during the downward fall of a projectile motion. Then you must know about the sign of the G. I have explained well in the two different ways. The sign of G related to the motion of a particle object, and during that always we take the negative sign. And I also have explained the sign of G related to the displacement, but there we have to use the reference. If the distance of displacement is positive, G will be negative. If the distance will be negative, the G will be positive, means it will be opposite to the distance of displacement regard related to the reference point uh, of the from the trajectory, taken from the trajectory. Then at the end, I'm providing you some link of the topical questions. I'm sure you can solve now the questions from there very easily. And I'm also providing you the link of the notes. You go there and study well, go through it. If any question you can ask me directly. You inbox me, and also I am attaching here the one site is very important, very easy and interesting, just to analyze, just to see, observe, do different types of activity related to this topic, and enjoy and learn the topic. Okay, the last one. And at the end, I would like to say thank you, thanks for watching, and I hope that you will like and subscribe my channel.